Alright guys, hope you're staying safe out this new year. Let's go ahead and start with another tutorial to see how we can add the edge maps to your mesh using the procedural shading technique using Blender. And let's go ahead and start it. I'm just using a model that I've created with insert faces, and I'm just gonna add a quick shader. And you can see I'm just gonna boost up the metallicness to see if the mesh really looks like a metal. And let's go ahead and add some kind of bit of color to just highlight them. And there are a few tips and tricks to actually use them using the IQR, which I'll be updating on my later tutorials. And for now, just follow this. We are going to add a bevel node which will calculate the edge data from your mesh, and also include the um, geometry node, not the geometry node actually, it is the geometry data which is holding your mesh geometry details, right? So what this is going to do is actually bevel has the edge data, and you're going to take the normal data from your mesh on the geometry, and you got to actually manipulate the vector math, and you got to apply the dot product, and you got to really connect the uh, output socket from your bevel node to your first vector, on the output socket from your normal node to the second vector. And that's what's going to happen. It's actually going to create and or calculate the edge data that your mesh is actually holding. Cool. That's not it, right? So still we need to add some more manipulations on math, and I'm just gonna take the value, use a normal math operation, and I'm going to choose something like a divide operation onto this and plug that to the base color. And you got to see there nothing popping over here because Blender is not yet finished calculating the data, because we don't have sufficient information to manipulate and calculate the data. And let's go ahead and start doing that. So for which I'll be needing is to go search for the value node which I really needed. That should be available in the input, and there you go. Yeah. So the math operations need two kind of inputs, and one is already plugged in from the divide operation that you've sent, and second one goes through there. I'm gonna really change the values based so you can actually see that the data is actually populating out neat and clean. But that's not it. Still, we're gonna do fine tuning on this to see which value matches the great accuracy. And you can change this value based on your mesh, your mesh details. This is going to be completely refactorizable. You can change it at any given point of time when you want it. And there you go. I can see some kind of good edge maps over here, nice, clean, and it's visible. Also, Blender has did an excellent job in calculating the edge data and where my shadows will be affected badly. Cool. So what we can do is we can actually plug in and check the actual output versus the calculated manipulated edge data output from Blender, and we'll see the preview how that looks really good. And I can see the position of this geometry is really good, and also the bevel and the normal data that looks really good for me. But this is not accurate as I wanted, so I'll be going and making sure that this has some kind of like a fine-tuned edge. So I'll be dealing with this value a little bit, changing them with respect to time to get an accurate edge data. Let's go ahead and do that. Somewhere around this value, I think it should be okay. Remember this, guys, right? So if you want to fine tune it, you gotta play with the data and see like what kind of value really matches your style preference, right? So this looks good for me because the edge data is nice and clean, and you see the red portions are referring to the areas where it will affect the shadows, and it's pretty good. And Blender has really done a nice job over here. In rest of the areas which are shown over blue or pink or violet, whatever you call, that's gonna be affected by the light. They'll not be affected by the shadow. So let me plug that into the base color data. I'm gonna do some bit of more math manipulations to see if I can fine tune this, and there we go. So here you see the shadows are the one which are affected really great over here with respect to the light. I do see some kind of the values that are shattering here and around. The shadows are a bit creepy than what I expected. So what can we do to get that fixed? Cool. So with respect to the math manipulations and vector manipulations, the value ranges from 0 to 1. Any number that values from 0 to 1. What about it's like 1.1, 1.2 or something like that, right? So you gotta really clamp that information and keep it really within the boundary, so that will make you to get your results fine-tuned. I'm trying to do something different here. Let me try to actually see if that renders really quick. I try to use this cycles render because it's more accurate than what I needed from Eevee. That's a real-time render engine that Blender offers by default. But I'm a fan of cycles though, no question why. So cycles has a really great ray tracing stuff where you can see the light shadows and the ray. You can control the light rays using different kind of nodes. We cannot do that with the Eevee. No wonder why. Okay, this is how it looks without the effect, and we will be plugging the effect to see if that really worked, right? So there you can see, and there is like no hard crisp shadows, and there is no proper edge detailing, and the mess what it made is it looked so artificial. It doesn't look natural when, especially with respect to the metallic shaders. And now there you go, I've plugged in the edge, and you can see the edge details are more crisp, clean, and it's like taking up the persistence on that corners and edges where it's gonna affect the shadows. I'm really liking this a lot, and you can use this for any kind of mesh that you have it in a real time. This technique works for all kind of topology and mesh. Make sure that your topology lies on with quartz, so that gives more cleaner edge data than your n-gons. That's according to my preference. You can change if you want. You can add a map range node if you wanted to really control out the data over the XYZ coordinate to keep the minimum value and the maximum value separated at each cost. Cool. So this is gonna take a while because it's gonna calculate the minimum value and the maximum value and put them across to your render data. So you gotta wait for a while to see how that's really looking over here. And I feel this is pretty much good, and I've just clamped them everything, and I've just kept only the values from 0 to 1, and I've just grouped them, right? So I can use it for any kind of projects if at all, if I want it in future. Maybe you can follow the same thing if you like to do it, or you can keep them separate as per your wish. Cool. So there are a bit more stuffs which I need to add it to the input, which I really wanted to control. If at all, if I wanted to control, I'm just gonna keep the value plugged into my input, so I can control the value through my shader tab. That should pop out there. I'm gonna rename this for my convenience so that I can easily find out what's really happening over there with respect to my node group. And if you don't have the node wrangler add-on enabled, you can go ahead and enable the node wrangler add-on from your preferences. That's the setting from the Blender that will allow you to enable the add-ons. Cool. So we gotta wait for a bit to see how this really looks interactive. and I've plugged in two uh, input sockets that I wanted to really control, and see how the mesh changes and how the edge shadows changes on the fly. So I'm just gonna find out two values which I can really use it for, and yep, I have plugged them in. I have changed the color. You can keep any color you want. Totally depends on your preference. I'm gonna change some settings though over here to see, set some attributes and texture scales if you want, a texture setup if you want, but I don't want to add any kind of texture. So the cool thing about this is you can plug in your textures to your edge viewer to actually hold the texture on the edges, not on the entire mesh. That's one cool stuff about this. So I think we're almost done. Gotta wait for a little bit for the render to have a more cleaner and crisp view before I decide on anything. Cool. That looks really great for me. Okay, I'm out of the group view and I've plugged in. You can really see how the mesh looks, the shading, and this is the clean edge data which I wanted to project it for any kind of mesh that I'm creating. The cleaner edge view, how the mesh is going to react when it is actually facing the light and facing the normal data, right? So this is the easiest way of calculating the edge data and adding edge maps for your meshes. You can use the ambient occlusion technique though, but that's the legacy technique and that does not work always, or it does not work for all of your meshes. So there are tutorials in YouTube illustrating the use of ambient occlusion to calculate the edge maps, but I'm not a great fan of that. So I decided to use the bevel data and the geometry's edge data, and that's it. And I can add two value nodes to actually keep the value consistent or persistent. I can change with respect to time, maybe whenever I wanted, or if you wanted to leave it plain, you can leave it completely upon your wish. Now we're gonna wait for some more time for this render to get at least some kind of minimal precision look that I wanted. Let's wait for it. The beauty of using this edge maps calculated by bevel is I'm gonna play with kind of like values over here to really see how that looks. I'm gonna change it and plug it into different sockets of BSDF to see what kind of effect that gives. So you cannot if you want to use it for different variations, you want to give some different variations to your mesh, you can go ahead and do that by plugging into the different sockets of principal BSDF. That's the shader available on Blender for you for free. And there we go. Emission, if I wanted to emit something really on that particular calculated edge data, you can go ahead and use this technique. Possibly you can create multiple variations with respect to emission, with respect to normals, with respect to roughness, metallicness, sheen, and so on. So it's gonna take a while for it to actually have good precision view on the render, and it's happening. Wait for a while. I can actually see that it's actually emitting the difference value from whatever the Blender has calculated. Good job. Okay, I'm gonna plug this to the base color, and I've already enabled the wireframe from the overlay to actually see how the normal data is reacting with, just to see and just to have a precise stuff over here in my view. All my edges are covered with the calculations. Yep, Blender did a really good job. Cool. So you can turn the face orientation on to see if you really wanted to see if the faces are aligned to the normal, but I already checked it So it is. And in the rendered view, you can use the render precision to actually change the view that you wanted to actually look on for. If you choose the position, it's gonna see how the position of the mesh is aligned with that of the normal, so which you're taking a look at it right now. I can change different values to see if you're okay with the result or if you still want to go ahead and fine tune it. So we can turn off the wireframe value off, because I have already seen that the edge data is calculated nice clean. This will not be rendered onto your actual render image, so you need not worry about that. So let's keep it simple. And I can do a bit more to actually see if that it's actually good. All right, let me look at the close edges. What's happening over here? It's actually affected. All right, wishing you guys a very happy new year and stay tuned for more videos. Thank you. Bye bye.